Is my screen is visible? I think it is visible to you. Okay. Last class before your exam, I hope everyone exam was good. Questions were quite easy. Okay. Before your exam, we were doing your the sedimentation tank part, right? So we have first discussed about the screening, then after screening, how the particles settle down with a detention period that is in our sedimentation tank. Sedimentation we have this one discussed. Okay. So after we have told in this one in sedimentation part that the suspended particles, okay, which has a specific gravity than less than that of water, so those particles keep on suspended, and so in that sedimentation tank, if you keep that particle in a fixed still position for a detention period of like 24 hours or something like that, so what will happen, the suspended mud particles it will settle down automatically. Okay. So after that, after it passes through the sedimentation tank in that process, okay, it comes to now it comes to a tank, okay. Like here what happens, though it is said that in the sedimentation tank, the suspended particles, it settles down, okay. But what happened in actual is that the very fine suspended particles, okay, and the also the colloidal matter that is present in the water, it cannot be settled down in the sedimentation process. Okay, so it's not possible for in the sedimentation process to settle down the very fine suspended particles and also the colloidal matter that is present in the water. Okay, so with an ordinary detention period, that is not possible. Okay, so now but anyhow we have to remove that very fine suspended particles anyhow, isn't it? So how it is done? So these particles, it can be easily removed by how, what is the process? If you suppose, if you increase the size of that particle, okay, if you increase the size of that particle and if you make it a flocculated particle, so what will happen? That particle will easily settle down. Okay, this is obvious, because if any light particle is there, if you make it a heavier one, by adding something to that, then it will become heavy and it will obviously automatically it will settle down. Yes. So similarly, in this process of sedimentation aided with coagulation, what we do is that that's very fine suspended particles, we convert it into a flocculated particle. Okay. How? By simply adding chemical compounds, okay, which is also known as coagulants, to the water. Okay. And you in the mechanical process, it is thoroughly mixed. Okay. So when you add some chemical compounds or these coagulants in the water, and when it is mixed thoroughly, so what happens is that a gelatinous precipitate is formed. Okay, it is a gelatinous precipitate is formed, which is also known as floc. Okay, so this very like this colloidal particles that is present in the water, or the very fine suspended particles that is present in the water, so what it does, it gets attracted to when these chemical compounds are added. Okay, to these chemical compounds, these colloidal particles, it gets attracted and it gets absorbed, okay, in this flux. Okay, as a result of which a bigger size these particles, flocculated particles, are formed, and as a result these particles settle down easily. So this is the whole process of your sedimentation aided with coagulation. Now your two terms will come. One is your coagulation and the other one is your flocculation. Okay, so this coagulation, it is a process of what? Destabilization. Okay, it is a chemical technique where you destabilize the charged colloidal particles. The colloidal particles, it carries some charges, okay, which are most this one negatively charged. Okay, the surface of the colloidal particles, it has some charges which is a negatively charged ion. Okay, so this coagulation, it is a chemical technique by which you destabilize. Okay, just wait. Hey, Oinam, the link is correct. I don't know what why it is shown, because other students, they have joined. Okay, I don't know. Maybe some issues with her network. Anyways, okay. Um, so, so this is the process by coagulation. It is the process by which you can destabilize the charged colloidal particles. Okay. On the other hand, flocculation, it is a term. Okay. It is the mixing technique. Okay. When you mix, the slow mixing technique, which will due to which the this agglomeration of the destabilized particles will happen. Agglomeration means what? Like it will attract. Okay, so the whole process of mixing and in where the agglomeration is happening of the destabilized particles, so that term is known as your flocculation. Okay, so the entire process, after addition of your chemicals and mixing, so the coagulants and flocculation after it happens, so the whole process is known as your coagulation also. Okay, now this coagulated water, it is what it is done, it is finally made pass through the sedimentation tank. Okay, where these particles, the flocculated particles, it will now automatically settle down, and after it settles down, it is removed easily. So this is the whole process of your coagulation technique. Okay, so now the coagulants, okay, this it is generally necessary for cleaning the raw waters containing turbidities of greater than 30 to 50 milligram per liter. Okay, you see here, turbidity is greater than 30 to 50 milligram per liter. So only if the water, raw water, it contains a turbidity of 30 to 50 milligram per liter, then only you need to use a coagulant for the removal of the finer suspended particles. Okay. Okay, next is your we have told that we have to add coagulants to the water. Yes, we have to add coagulants to the raw water. So what are these chemicals which are used as a coagulant? Okay, so there are many four or five chemicals that are used as coagulants. So number one is your alum. So alum, then number 2 is your iron salt like ferrous sulfate, ferric chloride, and ferric sulfate. Okay. So these coagulants are generally used. So number 1 we will discuss, that is your use of alum as a coagulant. So what is the common name for alum? It is your aluminium sulfate. Okay. The common name for your alum is your aluminium sulfate. Okay, here it's written, you can see aluminium sulfate, which has a chemical formula of what? Al2SO43 into 18H2O, not into 18H2O. Okay, so this is your chemical formula for alum, and the most commonly used coagulant, okay, as a whole is your alum. Okay, please remember this, alum is most commonly used. Okay, now this alum, when it is added to the raw water, it reacts with the bicarbonate alkalinities which are generally present in raw supplies, okay, and so as to form a gelatinous precipitate of aluminium hydroxide. So what is happening? You can see this chemical reaction. This is aluminium like sulfate, okay. When you add it with the bicarbonate alkalinities, that is your calcium bicarbonate, okay. So what will happen? Calcium sulfate is forming and a flock is created here. Yes, that is your aluminium hydroxide. So aluminium hydroxide is your gelatinous precipitate. Just now we have told that a flock is, it's happened, a flock is created. So that is your aluminium precipitate is happening and carbon dioxide is going. Okay. So this is the whole chemical reaction. You have to remember it. Okay. You have to remember this chemical reaction. So, from the above equation, it becomes evident that the addition of alum to water, it imparts permanent hardness to it in the form of calcium sulfate. So, when you add alum to the water, it imparts permanent hardness in the form of what? In the form of calcium sulfate. Okay. And the carbon dioxide gas, the carbon dioxide gas which evolves, it causes corrosiveness. Okay, it imparts corrosiveness. Next, some of the important things which you have to remember is that here, okay, this one you see, the amount of alum required for coagulation depends on the turbidity and color of the raw water. Okay, so how much alum you have to give for the process of coagulation, so that will obviously depend upon the turbidity and the color of the raw water. So the dose of alum, okay, it may vary from 5 milligram per liter for the clear water and to up to 85 milligram per liter for very highly turbid waters. Okay, but there is a average normal dose which is about 17 milligram per liter. So 5 milligram per liter is for clear water, 85 milligram per liter is for highly turbid waters, and the average dose is your 17 milligram per liter. Okay. Okay. So next. Okay, and also about the pH. Also about the pH. This pH is about the pH should be between 6.5 to 8.3. Okay, this if it is the pH is between 6.5 to 8.3, that means it will form a good flock. Okay, so the pH value, it should be maintained between 6.5 to 8.3. Next is your number 2. Okay, one more point. One more point is important. That is, so everything has a drawback, isn't it? So the drawback of alum, okay. So the only drawback in the use of alum now is that the effective pH range for its use is small. So it is 6.5 to 8.3. So, and in many cases require the addition of external alkali salts, thereby rendering it costlier. So what happens? The drawback is that the pH range is small. Okay, so it may require to add some external alkali salts. So what happens if you like again add some other alkali salts? So the cost will go on increasing. Okay, since it is for very low pH, so it is like you have to add more and more of the coagulants. So it might be costlier. It will be costlier. So and so that is the only drawback of using alum. Okay. Next is your like use of copperas as coagulant. So copperas, it is the name given to ferrous sulfate. Okay, ferrous sulfate, it is the common name. And what is the chemical formula? FeSO4 7H2O. Okay, copperas, it is added to raw water in conjunction with lime. So lime may be added either to copperas or vice versa. So here what is happening? First of all, the common name for copperas is your ferrous sulfate. You have to remember first this point. It is the common name for ferrous sulfate, and the chemical formula you have to remember. Okay. Then copperas, it is added to raw water in addition with what? In addition with lime. So first you can add lime also at first, okay, or you can add copperas also first to the water. Okay, so you vice versa process can take place. So like when you add lime to the water first, so the chemical reaction will be different, and when you add copperas first to the water, so in that case also the chemical reaction will be different. Okay, so first reaction you see when lime is added first. Okay, so what will be the chemical reaction? This is the chemical reaction. Okay, FeSO4 7H2O plus hydrated lime, that is calcium bicarbonate, oh sorry, calcium hydroxide, gives your calcium sulfate plus ferrous hydroxide. Okay, this is this ferrous hydroxide it is giving plus 7H2O. So like when you now add copperas in earlier to lime, so the chemical reaction will be this one. Okay. So here it is also ferrous hydroxide. So now this ferrous hydroxide, it will now get further oxidized, okay, forming what? Forming ferric hydroxide. So this ferric hydroxide is the ultimate flock, okay. It is the precipitate, and it is the ultimate flock that happens in the chemical reaction. So this copperas, it is like used extensively where the water is not colored. Okay, it is used as a coagulant when the water is not colored, and it is also cheaper than alum. Okay, and also it functions in the pH range of what? 8.5 and above. Okay, here the pH range is greater than that of alum. Also it is cheaper than alum, and also it is used when the uh, color of the water, it is not colored. Okay, it is colorless. Okay, so next is your number 3 is your use of chlorinated copperas as coagulant. Okay, so now when you chlorine is added, okay, to a solution of copperas. Okay, copperas was what? Just now we studied copperas is your ferrous sulfate. Okay, copperas is your ferrous sulfate. So when you add chlorine to ferrous sulfate, okay, to a solution of ferrous sulfate, okay, these two will react, okay, and it will form ferric sulfate and ferric chloride simultaneously. Okay, So what is the chemical reaction? This is the chemical reaction. You can see this ferric sulfate and ferric chloride, it is happening simultaneously. Okay. So this, like the resultant combination of this ferric sulfate and ferric chloride, it is together known as your chlorinated copperas. Okay, that is in our heading, that is chlorinated copperas. These two, ferric sulfate and ferric chloride, both together is known as chlorinated copperas, and it is a, you know, it is a very good coagulant for removing colors. Okay, where especially where the raw water is having a very low pH value. Okay. Okay, then okay, so next is your, like, both these chlorinated copperas, okay, that is ferric sulfate and ferric chloride. So along with the lime, okay, if you add lime to ferric sulfate, or if you add lime to this ferric chloride, so what will happen? It will create one effective coagulant. It will act as an effective coagulant, and the combination of these two is quite effective. So this is, you can see these two, this is one reaction, okay, and this is another reaction. So here what is happening, a ferric, the same, this one, ferric hydroxide precipitate is forming, okay. So this ultimate ferric hydroxide, it is a flock, okay, and it will be removed. So it will settle down and then it will be removed. So this ferric chloride, it is ferric hydroxide or ferric sulfate. So the ferric sulfate, you know, it is in the pH range of 4 to 7, okay, and above 9. So ferric sulfate pH range is 4 to 7 and above 9, and ferric chloride, it is a quite effective in the pH range of 3.5 to 6.5 and above 8.5. So you have to remember both this pH. Okay. So and then our last is your use of sodium aluminate. Use of sodium aluminate as coagulant. So you see, besides alum and iron salts, sodium aluminate is also sometimes used as a coagulant. So this chemical, when it gets mixed with water, it gets mixed with raw water, it will react with the like the salts of calcium and magnesium that is present in the raw water, and it will give the precipitate of calcium and magnesium aluminate. So these three are the chemical reactions for your sodium aluminate. Okay, and you can see here that it gives a precipitate of calcium aluminate. Okay, you can see here it gives a calcium and magnesium salts, okay, present in the raw water, and gives a precipitate of calcium or magnesium aluminate. Okay, so this coagulant, it is 1.5 times costlier than alum, and therefore it is not used for treating the ordinary public supplies, and also it is very useful for treating waters which have a natural desired alkalinity, okay, and which cannot be treated with pure alum. So this coagulant sodium aluminate is used as a effective coagulant in that case. Okay, but it is like somewhat costlier than the alum. It is 1.5 times costlier. That means you can assume how much costlier it is. Yes, so it is generally avoided, but it will be effective. It is effective in the where in the that is having natural desired alkalinity, and which cannot be treated with your pure alum. Okay, so this four These four you have to remember, and the chemical reactions. There is no other way. You have to remember the chemical reactions also. So this four: use of alum, use of phosphorus, use of fluorinated phosphorus, and last is your use of sodium aluminate as a coagulant. Okay. Now you watch one 3-minute video. I want to show you one 3-minute video so that you can understand the whole process of flocculation and coagulation. Okay, if you watch a video, then it will be more clear to you, I know. So you just watch this video nicely. Oh, hello. Okay. I was playing the video. I forgot to share. What?
It's all right, ma'am.
I was thinking what happened. Now I just saw after the video ended, I saw it is not shared. Okay, it happens in online. Okay, let me share now. Now it is visible, right?
Yes, ma'am.
Okay.
Flocculation and coagulation are fundamental for wastewater treatment and were already used by the ancient Egyptians in 1300 BC. This sample of muddy-looking water from a paper mill has a very high turbidity due to the presence of many suspended particles. Adding flocculants will cause that the small particles clump together to bigger flocks that settle down. So let's have a closer look how flocculation and coagulation work in detail. Turbidity of muddy-looking water is caused by two types of particles, organic and inorganic. Organic particles are, for example, algae and bacteria, whereas inorganic particles are, for example, clay and silt. Both particle types have in common that they are able to float because they are too small to settle by gravity. Suspended particles that are too light to settle down are called colloids. Almost all colloids have negatively charged surfaces. The negatively charged surface will attract positively charged ions in the water, so the colloids form a first layer. The effect is very similar to magnets. Like poles repel, but opposite poles attract each other. Over time, colloids form a second, diffused layer with positively and negatively charged ions called a double layer. The double layer creates a responsive force which prevents two colloids from stacking to each other. The colloids stay suspended in water and move around to avoid collision with other colloids. To overcome this behavior and to clump colloids together for particle settling, flocculants are used. Typical used flocculants for particle settling are alum and ferrix. Alum and ferrix are ideal as flocculants because they form a high number of ions when they get in contact with water. These ions will bind together with the colloids and neutralize responsive forces. Mixing the water allows the colloids to stick together, to form bigger flocks and settle down to the tank bottom. Within wastewater treatment plants, the flocculation process is normally separated from sedimentation. Under gentle agitation, flocculants are added in the mixing tank before water is entering the sedimentation tank. Here particles are settling down until they build up a sludge blanket, which is then removed. Thanks for watching, and if you like our 3-minute tutorials, please subscribe and don't forget to give a thumbs up.
Okay. So it was a nice explanation in the video. I hope coagulation is and flocculation and the whole process is clear to you now. Okay. Okay, then let's wind up today here. Okay, so today's class, let us wind up. Next class, I will be doing one numerical related to this coagulation, and after that, we will go to the next treatment. Okay, that is filtration. We will go. So let me take your roll numbers. I am writing down the roll numbers in our this physiochemical group itself. I will be posting there itself. Okay, the roll numbers. Some of the students they couldn't join. I don't know why. Okay, who is present? Can you tell me serially? Roll number one. Okay, I have.
Yes, ma'am.
Okay, just wait. Okay, I have one attendance sheet. Let me fill up in that. Okay, roll number 1 is there. Yes.
Yes, ma'am.
Okay, 2.
Yes, ma'am.
Okay, Deepak, today is your first class, right?
Yes, ma'am.
Okay, no problem. From today, you keep on attending, and later we will see, okay, about your first session.
Okay, ma'am. Thank you, ma'am.
Sure. Roll number 3,
Present, ma'am.
4,
Present, ma'am.
then 7, 8, 9,
Present, ma'am.
12,
Present, ma'am.
okay, 14,
Present, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.
Apa puja?
20.
No, ada tunggu juga aku dari sini. Ya, baik ya. Baik aja.
Yes, please mute yourself.
Ma'am, 20 present.
Okay, just wait. Somebody's mic is on. Yes. Okay, 20 is present, right? Okay. 21,
Yes, ma'am.
then 22,
Yes, ma'am.
26,
Present, ma'am.
29,
Yes, ma'am.
30,
Present, ma'am.
45, 52,
Present, ma'am.
54,
Present, ma'am.
59,
Present, ma'am.
okay, 62, 107, Madhusmita, Madhusmita, okay, 76,
Ma'am.
okay, 77, 76 is this one, just now Madhusmita or
Yes, ma'am.
76, okay, 76, okay, then 77, 77 is present. Okay, 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 Hanger. Then 78,
Yes, ma'am.
okay. 84,
Present, ma'am.
okay, 88,
Okay,
okay, 90,
present, ma'am. 90.
okay, 92, 93,
Yes, ma'am. 93.
okay, 95, 102, 108, 109,
Present, ma'am.
110, 112,
Yes,
One,
ma'am.
112, okay. 113. Okay, so whom did I left out? 45 is present, okay.
Hello, ma'am.
Yes, then 107 is also present. Just wait, okay. 107. Then roll number 92. Okay, 92 is present. Then 7 is also present, I guess. Just now. 77. 77 I have given. Roll number 7. Okay. Okay, did I miss anyone?